Assalamu alaikum everyone. I hope you're all doing well. Okay, this is Sir Shafat Khan on your screen. I hope everyone is in their best state of health. Today we are going to do Edexcel A2 math. Yes, we are going to do Edexcel math. I generally don't put my math videos on YouTube, but now I think it's the best time to put them so that some of the students might get an idea of the teaching style. All right, so we are going to be doing P3, right? And it's A2 math that we are looking at, all right, because P3, P4, and an optional subject is there in Edexcel A2 math. Pearson Edexcel A2. Okay, so let's get started. A topic we're going to do today is differentiation. And because this is P3, this is not P1 or P2. Therefore, you need to have some prior knowledge before getting into this differentiation phase. So by now, I'm assuming that you already know what differentiation is. In this chapter, we will study a differentiation of trigonometric functions, of logs and exponentials, and differentiate using the chain, product, and quotient rules. Okay. All of this has been covered previously as well, except for the trigonometric and exponential and logarithmic part. But you guys, I'm assuming, already know what quotient rule, chain rule, and product rule might be in your previous lesson. Okay, so let's get started with this. So this is your prior knowledge check. I hope everyone should know how to differentiate all of this stuff. Okay, because now the questions are going to get a lot tougher as compared to what you have been studying so far. Let's get started then. Bismillah ar-Rahman ar-Rahim. Okay, so first of all, you could be able to differentiate sin x and cos x. Okay, so what's the differential of sin x? Okay, so if for instance, if y equals sin x, the differential of sin x is always cos x, and the differential of cos x if y is cos x. What's the differential of cos x? The differential of cos x is always minus sin x. These are the two differentials I'm assuming you all remember. All right. Now, apart from that, this first example is actually not required by the exam syllabus. So it's okay if you don't know what this is. Right. So I'm not going to spend time on this one. Instead, what we can do is we just can quickly go on to the final product of this derivation. And that is, if you have sin x given to you, the differential of sin x is cos x. But always remember one thing, then what if you have a number written right over here inside, over here? And always remember that whenever you are differentiating sin x and cos x, you are always differentiating in radians. Okay? The angles are measured in radians and not in degrees. Okay, we will mostly be concerning our entire um, practice around the radians. Okay, so for example, if you are asked to differentiate sin pi by 3x, that's in radians. Okay, now apart from that, I hope everyone remembers what radians were, right? Radian is just another technique of measuring an angle. Pi radians equals 180 degrees. Anyways, if y equals 2x, for instance, if there is a number other than just x over here, how would you differentiate that? Basically, there is an integer or a non-integer number or just any constant is there written right next to the x. What you need to do is, first of all, you differentiate the trigonometric function. Okay, it's cos x, right? Differential of cos is negative sign. So you have to write down negative sign. But always remember, now this is 2x, right? Cos 2x. So the differential is going to be negative sine 2x, not just negative sine x. Okay, it's going to be negative sine 2x. Once you have differentiated this trigonometric function, next step is multiply this differential by the differentiation of what's inside this bracket. Okay, whatever is inside the bracket, you multiply this bracket by the differential of that. What's inside? It's 2x, right? So what's the differential of 2x? The differential of 2x is going to be just 2. Just multiply the whole thing by 2. And this result that you've gotten is actually going to be equivalent to dy by dx now. Okay, that was your y. And so the final answer that turns out to be negative 2 sine 2x. So that's your differential of cos 2x. All right, so if you have y equals cos kx, then the differential is going to be negative k sine x. Sine kx, I mean, not just x, kx. Whatever the trigonometric function is with whatever angle, the differential will also have the exact equal angle. Okay. So if that is kx, this is also going to be kx. If that is cos kx, this is going to be negative sine, but kx. Okay, and multiplied by k. So that's your first differential. Same applies on sine as well. Sine. If you have to differentiate sine, or just a second, if you have to differentiate sine, then what do you do? For instance, you have this trigonometric function given y equals sine kx, and you need to find out the differential of sine kx, what you're going to do is first you differentiate the trigonometric function. It's going to be cos kx, right? And then multiply this by whatever is inside the differential of whatever is inside. So you have kx inside, so you multiply it by k. So you are left with k cos kx. Simple as that. Okay, now let's move down. We have some practice questions right over here. If you want, you can solve them. I'm going to solve this one for you guys. Right now we have 3 cos x plus 2 sine 4x. We need to differentiate that. So dy by dx is going to be, now 3 can be written as it is. It's just a product rule. So just write the 3 as it is. Don't have to worry about it. But at the same time, cos, what to do with the cos? So cos x, the differential of cos is negative sine x, right? Then added, then what about the 2? Whenever it's being multiplied with a trigonometric function, you don't have to worry about it, just copy it as it is. Now, what about the sine 4x? Sine 4x, differential of sine 4x is going to be cos 4x, not just cos x, cos 4x. And then you are also have to multiply it with the differential of whatever is inside. So differential of 4x is going to be just 4. Now simplify that. This is going to become negative 3 sine x along with 8 cos 4x. That's your differential of this equation. 3 sine x plus 8 cos 4x. And if you just look at it right over here, we got the answer, right? Wait, we have a negative answer. Yeah, negative 3 sine x plus 8 cos 4x. So yeah, we got it right. Okay, you can practice out the other two as well. This is the Pearson Edexcel textbook, by the way. Now, example 3. If you have a curve equation given over here with an interval given over here, the domain given over here, find the stationary points on the curve. Right, so this is also a review of your prior knowledge, but with advanced of that. So y equals half x minus cos 2x. If this is the equation of the curve given to you, and you need to find the stationary points. First of all, stationary point is a point where the gradient, where the dy dx becomes 0. This was a quick recap of the previous knowledge. And the interval is from 0 to pi, correct? And you need to calculate the stationary points on the curve. Yeah, in this interval from 0 to pi. How exactly do you go about this? Simple. First, differentiate it. Dy over dx. So half x is just going to become half, right? Differential of half x. This is 1 multiplied by it. It's going to subtract 1 from it. So you just left it half. What's the differential of cos 2x? Differential, you put the negative sign as it is, by the way. Now, differential of cos 2x. Let me just put a bracket over here just to simplify that. Differential of cos 2x is going to be negative sine 2x, right? Negative sine 2x. But at the same time, you have to multiply it by whatever the differential of whatever is inside, multiplied by 2. Simplify that. Half plus 2 sine 2x. Now, because it's a stationary point, the dy dx must equal 0. Now we can simplify that to get the value of x. The negative half equals 2 sine 2x. So sine 2x will equal negative 1 over 4. And then 2x will equal sine inverse of negative 1 by 4. Always remember to do the calculations in the radian mode. And whatever you get, just divide that by 2. You get the value of x. Once you have the value of x, you're going to use that value, put it back into this equation to get a value of y as well. And just look at the solution over here. Yeah. And also, you have to keep the interval in mind. You have to keep the interval in mind from 0 to pi only. Okay? So you have to ensure that the two values that you get, their x values, lie in this interval. Over here, we first differentiated it. Then we got the value equal to 0. We got sine 2x equals to negative 1 over 4. Now the 2x can give us multiple values, right? Because you know that whatever value you get, that's the alpha. We just keep on adding the 2 pi to it and keep increasing the value. You can keep increasing. I don't have to revise this with you guys. This is your prior knowledge from trigonometry, okay? And so the values of x are just gonna half all of these. Okay, you're gonna get 2 of these values. You have to ensure that both of them lie within the range that you have. So both of them don't actually. This one does. 1.7. And 3.2 does as well. Because it's still pi, right? 2.142. Yeah. 2.02 does. So you get the two corresponding values of y as well. So this is your first stationary point that you've gotten, and this is your second stationary point you've gotten for the same interval, 0 to pi. I hope that makes sense. Okay. Stationary point is a point. We just found the coordinates of the stationary point. And see, it's even written right over here. Watch out. You have to use your calculator in the radian mode. Okay. Make sure to switch it to the radian mode. And so, yeah, range is from 0 to pi. Okay. Have to be careful. The 2x is going to be from 0 to 2 pi. Obviously, we multiply the two sides of this answer. Once you're done with this, you have a whole exercise to solve. You can solve the entire exercise if you want. Okay. Well, I think I'm gonna do question number 7 for you guys. I think I've already done that. Let me just check my notes. Let me share the notes with you guys. Okay, I think this is question. Okay, this is one of those questions that you have in the exercise. So, yeah, if you want, you can first solve it yourself and then look at my solution over here. All right, but I just quickly go over the solution. Y equals 1 plus 2x sine 5x over x. Now you know that the two numbers or the two components of the equation are being divided. So you have to apply the quotient rule, right? What was the quotient rule? You can recall it. For the quotient rule, you have to first differentiate the first number and multiply it with the second number, then minus this differential of the second number multiplied by the first number divided by the second number's whole square. Okay, I've done that. How do you differentiate the first number? The one is going to result in a differentiation of 0. Now for 2x and sine 5x. So again, you have to use the product rule over here because now they are being multiplied. Okay, how do you multiply the two? First number is differentiation. This is 2 multiplied by second number as it is. Plus, if second number's differentiation is cos 5x multiplied by 5 into the first number as it is. Okay, so you differentiated the first component itself, then you multiply that by the second number as it is. So you are actually, I've combined the two rules together. To differentiate this alone, we need the product rule, and to differentiate the whole thing, we need the quotient rule. Okay, so I've differentiated the first component, then subtracted it, and then the second component is just going to be the differential of the second number multiplied by the first number copied as it is, divided by the second number whole square. Okay, and then we can just simplify it, open up the brackets and everything, and then you put in there. But be careful while opening up the brackets, be careful about the minus sign and the plus sign. Okay, these two just get cancelled, and then after cancellation, everything goes as a final. Okay, this can be a bit tricky if you're not into practice already. So you should have enough practice by now. Right, now if I find the gradient of this curve, y equals 2 sine 4x minus 4 cos 2x at the point where x equals to 5 by 2. You need to find out the gradient. So to find out the gradient is again dy by dx, right? Gradient, what is gradient? Gradient is the dy by dx, the differential itself, right? What is differential? This is the gradient of a tangent to this curve at that particular point, right? Dy by dx in this case is going to become, now sine 4x, if you differentiate that, that's going to become cos 4x multiplied by 4. But you already have a 2 over here. So the 4 multiplied by 2 is going to result in an 8 over here. Okay, so 8 cos 4x minus, now you have to also differentiate this component, 4 copied as it is. But what about cos 2x? Cos 2x is going to be written as minus sine 2x multiplied by 2. So minus sine 2x multiplied by 2. Right? Then open up the bracket, simplify and everything. Once you've done that, you've gotten the equation for the differential. Then you put in the value of x is 5 by 2. Okay, they've told you that the value of x is 5 by 2. You take that, put it in here, make sure to keep the calculator in the radian mode, and then simplify it, get the value of the gradient. Make sense? But always remember, if the calculator is not in the radian mode, you will not get the correct answer. Next question. A curve has this equation, y equals sine 5x plus cos 3x. Find the equation of the tangent to the curve at this point. Again, equation of the tangent to the curve would actually mean dy dx, first calculate the gradient, and then just use this point and that gradient to calculate the equation of a straight line, right? Y equals mx plus c, simple as that. So you have this equation, y equals sine 5x plus cos 3x, right? if you differentiate that, so sine pi of x is differentiated into cos pi of x multiplied by the differential of whatever is inside, meaning what multiplied by 5, along with plus 3x. After it's differentiated, it's going to become negative sine 3x multiplied by whatever is the differential of whatever is inside, so negative 3. Once you do that, and then once you have the equation of the differential, you put the value of x as pi. Okay, that's what the x component is. Just put the value of x as pi, and you get a value of the differentiation of the differential. You get the value of the gradient actually. Once you have the value of the gradient and you have this point, you can just use you can calculate the equation of the straight line by using the formula y minus y1 equals gradient into x minus x1. It's going to be a super quick formula to get to the equation of the straight line. Okay, and there you go. You have the equation of the straight line. Then next exam style question. The curve has this line y equals 2x squared minus sine x. Show that the equation of the normal to the curve at this point with the x coordinate pi is this much. You need to calculate the equation of the normal. I hope you guys do recall the fact that normal is a line that is perpendicular to the gradient itself, right? So if you have this line right over here, perpendicular to that line is going to be the normal. And if you remember the gradient of this line and the gradient of the normal, if the product is always going to be equal to minus 1. Okay? So if you need to calculate the gradient of the normal, you calculate dy by dx and you just reciprocate it and multiply it by a negative sign and you get the gradient of the normal then. Okay? Meaning you just calculate dy by dx and put it into this equation, calculate m2. That's going to be the gradient of normal. So what you do is you first take this equation y equals 2x squared minus sine x. You calculate the differential. The differential is going to just give you the equation for the gradient of this particular point, of this particular curve. So y equals 4x minus cos x, right? No explanation needed. You just put the value of x as pi, because again, the coordinate is pi, x coordinate is pi, it's given right here. Once you do that, you get the value of dy by dx. Once you have dy by dx, you can use that equation m1 into m2 equals negative 1, because this is not the gradient of the normal. This is the gradient of the tangent to the curve at that point. We need to calculate the gradient of the normal. You need to calculate the m2. You have the m1 right here. This is m1. Okay, this is m1. You don't have the m2. So to calculate the m2, you just put it into this equation. You get the value of m2 to be how much? Now you just see this right over here. I've done the same steps over here. M2 turns out to be negative 1 over 4 pi plus 1. Now, once you have m2 and you have the x coordinate, can you calculate the y coordinate at that point as well? Because we need a point, right? We need the coordinates of one point. To calculate the y coordinate, just put the pi back into this equation, you get the y coordinate. So we have the y coordinate right over here, which is 2 pi squared. We have the y coordinate, we have the x coordinate, we have both of them. And we also have the gradient of the normal. So once we have them, just put them into the same equation. Y1 minus y1 equals gradient into x minus x1. Rearrange, you get the equation, you get the final result. And I hope you guys do remember that whenever a question that asks you to show something, to show this equation, that question does not have the mark for the final correct answer, because the answer is already given to you. This question has marks for all the correct steps and working. So make sure to follow all the steps. Okay. So this pretty much finishes off the first exercise. Now, I think the questions after this are for logs. Yeah, these are the logs and exponents. So we can do them after we are done with the second exercise. Let me just go back to that. 1 second, please. Okay, here we are. We're done with 7 and 8. And 9, if you want, you can just do it. It's not that difficult either. You just look at this exercise, this example question right here, and you can solve it. Just take it as your homework. Okay? Take it as your homework. Now, after that, yeah, we are done with this first exercise. Now it's 6.2, differentiations of exponents and logs. And I think we can do that in a separate video after this. This was just the first exercise of differentiating trigonometric functions. We'll do the second exercise in the next video. Thank you so much. And please keep following this YouTube channel. And if anyone wants private tuitions for Edexcel Math, especially students who are currently in Hong Kong, because I'm based in Hong Kong, this is my WhatsApp number. It's 9651 2447. Hope I've written it correctly. +852. Code if you are an international student. Okay, so 965.2447 is my WhatsApp number. You can just register here, let me know, and I'll provide you online tuitions. I'll tell you the details over there. Thank you so much. Take care.